watched it and then.
Okay. So what we're talking about today is how to classify the quadrilaterals even further. After we call them parallelograms, then we can classify them more specifically. And the first one that we talked about was the rectangle. Rectangle has 4 right angles. But if we know that it's a parallelogram, all we have to know is that one of them is a right angle, because opposite have to be congruent, same side have to be supplementary, so we do have all 4. Or the other thing that we can look for is that the diagonals are congruent, that this is congruent to this. And if the diagonals are congruent, because a parallelogram diagonals are bisected, then they bisect into 4 little congruent parts. Okay, the next thing that we're going to look at is the rhombus. And by definition of a rhombus, what do we know must be true?
All 4 sides are equal?
All 4 sides are equal. All 4 sides are congruent. So, if we could show that, not that just opposite sides are congruent, which is what we would have to prove for a parallelogram, but that all 4 sides are congruent, that's enough to prove a rhombus. Or, there are other ways also. If a parallelogram is a rhombus, then its diagonals are perpendicular. So, if we have perpendicular, then we know it is a rhombus. Or, with a parallelogram, the diagonals bisect the angles. So let's look at this. Angle 1 would have to be congruent to angle 2, along with 5 and 6. 1, 2, 5, and 6 are all congruent. 3, 4, 7, and 8 are all congruent, because it's going to bisect those opposite angles. So we know the opposite angles must be congruent because that's part of the definition of parallelogram. But if they're congruent and bisected, it is now a rhombus. Okay, we know that must be true. Now, with the square, a square is going to have the 4 right angles and 4 congruent sides. So the right angles come from the rectangle part, right? And the 4 congruent sides come from the rhombus. So a square takes a little bit of both. And on your little sheet, we talked about all of these things. So, for a square, we said we need to show that it's a parallelogram, that it has one of the attributes of also being a rectangle, and then one of the attributes of being a rhombus. And we can pick. Mix and match. So let's take this little graphic organizer thing, and this is which of the figures? What do you call this one? That's the parallelogram. So, by definition, opposite sides must be parallel. We also know that opposite sides are congruent. We also know that opposite angles are congruent. We also know that given one angle and either consecutive angle, they are supplementary. We also know that the diagonals bisect each other. So I'm going to try to draw in bisecting diagonals. So on these, now when I bisect, what I'm saying is that this is congruent to this, and this is congruent to this. Not that they're congruent to each other, because if they were congruent to each other, it's not specifically a parallelogram. It has now moved into the rectangle category. Okay, so let's move over to the rectangle. I need to know it's a parallelogram. So I have to know all of this. Everything that's true about the parallelogram is true about the rectangle, and
all right angles.
All right angles, and the diagonals are congruent. Therefore, when they bisect each other into 4 equal parts. Okay, now, with the rhombus, everything that was true about the parallelogram is true about the rhombus. Plus, all 4 sides are congruent. Plus, how do they intersect? What do they form when they intersect? Perpendicular. Yes. When they do, they make congruent angles.
Because that's what angle bisections are.
Yep. parallelogram is true about the rectangle is true about the square. Everything that's true about the parallelogram is true about the rhombus is true about the square. So all of this stuff is true about the square. I'd run out of room if I tried to draw it all in there, but let's give it a shot.
Here we go.
You did it right there.
There goes the fan.
Maybe it's just you.
Okay, and it's also parallel everything that's true. I really am going to run out of space. Okay, does that make sense? That's our family. Now, if you're told a figure is a rectangle, then everything that's marked here you know must be true. So if they told you that this was x plus 3 and this is 12, find x. What is x?
X
9. Because we know those two have to be the same. Okay? So we use these attributes and then we can solve algebraically to find missing information. And then we can use these attributes to also prove which special quad we're dealing with. Okay, so here they are again. These were our good ones. Both pairs of opposite sides are parallel. Both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. Show that two sides are congruent and parallel. The diagonals bisect each other. One angle is supplementary to both consecutive angles. Those are the things that would differentiate a quadrilateral as a parallelogram. If we could find one of these plus one of these, either right angle or diagonals are congruent, now we can call it a rectangle. If we can pick one of these and one of these, then we can classify it as a rhombus. If we could say one of these, and one of these, it is a square. Now, when I give you assignments, something may look like a square, but you can't classify it that way. You have to go by the way it's marked. Okay? Your homework is out of your book. It is on page 228. Tonight, we're just doing 10 through 15, 19, 28 through 31, and 35. Keep in mind, your construction project is due tomorrow.
I'm a cheater. Do it before the deadline. Yeah.
Hey, Luis, let's
Okay.
31 or 23 to 31?
It is 23. Sorry. Thank you, Simon. And let me put my recording and I'll talk to you about that.
Do you have it today?